Thank you both very much. Next up, we have Yaron Vellner from B Protocol, and he will be speaking on a data extrapolation framework for risk assessment. So take it away. Thank you.
Yeah, hi everyone. Let me see if I know how to turn it on. No. Yeah. Yeah, need help, please? Yeah, I don't know, how do I start? Yeah, okay. Yeah, hi. Good afternoon, everyone. Yeah, so I'm Yaron from B Protocol. I'm also also a contributor to the Risk DAO, and this talk is mainly aimed, so if you're a lending market operator on L2 or on some altchains, or just run any low liquidity market on blockchain. So this talk is mostly to you. It's about how risk assessment is currently done wrongly on these L2s and altchains, how risk assessment can be done better, and also how risk can be improved in general. So this talk will be a bit technical. We'll start by trying to at least explain how risk analysis is done. We'll explain why the risk analysis that is done today doesn't really work or not work as smoothly also for altchains and layer 2. We'll show our risk model, how our risk model can help to monitor and set risk parameters for lending markets that suffer from low liquidity. And in addition, we not only analyze risk for lending markets, we also have a tool, a backstop tool, that can actually improve the status of the risk of these markets, and we'll show how it works. So the bottom line is that kind of the golden standard or the bad golden standards in risk analysis these days, so you fork compound code or other code, you launch it on some other blockchain. The code will work as is perfectly well. Typically you even have maybe almost the same assets. So instead of USDC, you have your local blockchain USDC, you have your local ETH, etc. So you might as well just copy the risk parameters from Aave on mainnet. But this is of course wrong. And this is wrong because if you do it in such way, liquidations might not be able to save you when market goes down. And liquidations are the backbone of any lending markets that wants to avoid bad debt. And further, so all the DeFi liquidation mechanism were kind of tailored to L1 on mainnet with high liquidity. They are, these days especially, we recently have a huge liquidity crunch after the Luna collapsing and the bear market in general. This will completely break on most L2s and on many L1s. So we show how to analyze these risks. So as a lending platform owner, you need a better risk assessment. And if you want not only to be aware of the risk, but also to take actions to mitigate it, so a backstop is what you need. So now we dive into the technical details. So basically, how is risk analysis done these days? And you have, very reputable and very strong teams, such as Maker Risk Team. You have Gauntlet, who are doing risk analysis for Compound and Aave. You have the Euler lending market risk team. Basically, they all take the approach of, let's see, what historical prices were, how much volatility there were. We look at crashes. We try to predict how users will behave when markets move the way they moved in the past. And then let's try from that to reason if liquidation bots will actually be able to facilitate the liquidation, where the outcome and the end goal of all of this analysis is eventually to set your LTV, loan to value, or collateral factor, which basically means how much you can borrow against every collateral asset. Of course, there are also additional parameters such as interest rate curve, collateral caps, borrow caps, etc. But in this talk, we mostly focus on the LTV. So historical prices, so you basically just take price trajectory from your favorite exchange. And of course, the more volatile the asset is, the more conservative the risk parameters are, because flash crashes are more likely to happen, and in return, liquidations are harder to execute. Now, this is basically the only point where if you do it for mainnet or for L2 or altchain, this is exactly the same analysis. The price of ETH on Arbitrum and on mainnet is exactly the same, at least the historical one. The price of USDC, or of wrapped Bitcoin is the same. So prices are all the same. However, so these are now the prices. And now, kind of the core analysis, trying to predict, now what if tomorrow price will go down by 20%? How many liquidations will I have? And how well they will get executed. So here is where the black magic begins. And there's a lot of work about so-called agent simulation, where Gantlet, MakerDAO, and the others really try to predict and say, if market will go down by 20%, so with some probability, X amount of users will recollateralize their account, repay their debt, add more collateral. So already on Ethereum, this is based on very sparse data. It's an educated guess, but still mostly a guess. But still, you can argue that Compound, Aave, Maker, they all have kind of a long history. Maybe these platforms already kind of know their customers, know their whales, their big actors, so they can fine-tune the model to act accordingly. But of course, if now you fork you launch your Aave fork or Compound fork on some L2, so you have really no idea, how your new platform, how your new users will behave, and it will actually take you years, to calibrate these parameters to the new behavior. Moreover, even if you say, maybe I will just observe Compound past, user history, and we'll try to extrapolate it somehow. So because liquidity on other chains is somewhat fragmented, and you need to have bridges, which in turn introduce some delay in the flow of the capital. So this, of course, also affects on the user behavior, which make the agent simulation model much more of a guess than a robust analysis. And finally, so from the price history and from the user behavior, you now say, so these are the amount of liquidations I will have. And of course, all of DeFi is currently based on liquidation bots who just take a flash loan, repay the debt, and repay the user debt, and then just close the position on their favorite exchange, decentralized exchange. And this is all done in a single transaction with a flash loan, without any capital, but also without any risk from the liquidation bot size. And this is the most obvious thing that breaks when we go to L2 or other altchains. Because if you see Ethereum liquidity, Uniswap liquidity, you can see millions, tens of millions liquidity for ETH, for DAI, for wrapped Bitcoin. But when you go, for these alt chains or L2s, so all of a sudden, if you take a token like Link, which is relatively well liquid on mainnet, and you can dump millions of it in a single transaction. So now if you go to some layer 2, all of a sudden, you see on the right-hand side, even if you only want to buy $90,000 or sell $90,000 of Link on this chain, you will already hit 12% slippage. For Up Bitcoin, I think for Up Bitcoin, this is on Aurora chain, so you cannot even sell 12 Bitcoin with a reasonable slippage. And Spell, maybe Spell is now also illiquid on mainnet, but definitely on Phantom. For example, Phantom has huge liquidity crisis. So you can no longer seamlessly rely on these flash bots to execute your liquidation. So this is an example for Moonbeam. So ETH is very liquid on mainnet. On mainnet, you can probably even liquidate $20 million in a single transaction with maybe 2 to 3% slippage. On Moonbeam, and this was before the Nomad hack, you couldn't even sell $200,000 with a reasonable slippage, which means you could not have liquidate over $200,000. And yet there were lending markets there with over $30 million as ETH collateral. So these are the challenges and difficulties. So the first step, and this is what we offer in the Risk DAO framework, is actually how to better analyze the risk of your lending market, how to set your LTV and collateral factor for a given market condition. And then in the last part of the section, we'll also present a backstop solution that not only helps analyze the risk, but also proactively helps you mitigate the risk. So the Risk DAO takes a bit of a different approach, which is very much appealing to early stage platforms, which are typically L2 or alt chains, but also if you have other low liquidity platforms such as NFT lending markets, etc. So in the traditional market, what you do is you try to learn the user behavior based on, so maybe you have Compound or Maker user behavior, and there are thousands of users, but that's quite low for serious machine learning algorithms. But once you learn the user behavior and you already have the historical prices, then you can build a model on how many liquidations will happen, when they will happen, and then how market will respond to them. In the Risk DAO framework, we take a bit of a different approach. So here we actually try to learn or predict the liquidation sizes. And this is something where data is much more available, because here we can use data also from standard futures exchanges, centralized futures exchanges, such as Binance, FTX, and others. The problem there is that you have a lot of liquidations, mostly for very popular assets, such as Ethereum and Bitcoin. So what we do is that we take this data and try to extrapolate it to the more exotic assets. So basically, instead of guessing the user behavior or learning it, we are learning the liquidation data and then just extrapolating the price trajectory, which in turn has much fewer assumptions on user behavior, which, like in DeFi, eventually there are very few whales that, count for most of the activity. So this is from analyzing, this is how we handle sparse user data. Further, to take into consideration the fact that there is low liquidity on L2s. So the thing is with L2s that you have very low liquidity. If we take, Up Bitcoin liquidity on, say, Arbitrum, but especially on Phantom and more exotic chains. So the liquidity is low, but eventually the price is not affected there by liquidations. So if there is an arbitrage opportunity, Eventually, someone will come and take it, but it will take time because this guy will have to bridge his Bitcoin, for his wrapped Bitcoin from Ethereum to Phantom or Arbitrum, and this will take time. So in our framework, we know how to model the DEX liquidity. We have assumptions which we learned over the time on how much time it will take to actually bridge it. And then we get this simulation model where actually, OK, if liquidation is being delayed now, so price is not affected, but if price goes down, then bad debt will be accumulated. And this is for the best of our knowledge. So right now, this is the only model that actually takes into account this flow of capital and the delays that it introduces. And finally, the risk DAO offer these risk dashboards with stress testing and recommendations for collateral factors and other parameters as a service to lending markets out there. So this is the risk DAO. And OK, so now with the risk DAO, we might be able to tell you, OK, because you are on L2, you are not on mainnet, you have to be more conservative with your risk assessment. You have to lower the LTV that you offer. And basically, you have to kind of damage or make the user experience of your users less appealing. But what if, OK, so this is, already this is not trivial to say. And as we saw, it's based on new mathematical models that captures more accurately the dynamic of the systems. But now let's say, OK, so now you are more aware of your risk. You have to be conservative, but now maybe you want to improve your risk parameters and eventually offer a better capital efficiency to your users. So this is where B protocol steps in. So in B protocol, so recall the main issue with L2 liquidations is that DEX liquidity is much more sparse. However, the prices themselves, behave the same as on mainnet. So B protocol design is actually to create a buffer and to pull user funds into a buffer that serves as a backstop to these liquidations. So now if there is a liquidation, the lending market no longer rely on flash bots and on the local Uniswap or SushiSwap fork liquidity, but actually it takes the liquidity directly from the backstop. So this is more appealing because this backstop has zero slippage. So it only charges you with a liquidation penalty, which is flat, independent of the amount of funds you want to liquidate. So now a lending platform can take the liquidity it needs for liquidation from the backstop. It executes the liquidation. And then, so you started with USDC. Now you ended up with some seized collateral, in this example, in the form of ETH. And here where the core liquidity of B protocol kicks in, where we actually have a formula which is completely free from human intervention. So it's not even operated by a bot. It's a simple smart contract formula that now offers the ETH for sale, where intuitively it is based on some adaptation of Care Finance formula for stablecoins. Only now we have ETH and USDC. So we simply normalize ETH price to the stablecoin price. And then Care formula actually kind of dictates a discount that one has to give when you are imbalanced. So the more ETH we have, the more anxious we are to get rid of it. So we'll give higher discount with respect to the market price, which we can take from Chainlink, or more generally from the underlying lending market. And then whenever this is being sold to the market, and typically it will be taken by some arbitrage bots, it is being deposited again, and now the USDC is ready for further liquidations. Now, what we actually benefited from here, we still rely on the DEX liquidity, but now with this buffer, so all the risk moves from the lending market to the backstop, but of course also profits are also shifted to the backstop, as opposed to, so right now in lending markets, they take all the risks from failing liquidation, but don't get any of the profits of successful one. So here we shift the equation, and now we have liquidity providers who are willing to provide backstop liquidity, take the liquidation risk, but also take the liquidation profits. So with that slide, I will conclude. Be happy to answer questions, and also you are welcome to reach out to us, either in the risk DAO framework or for the B protocol. So yeah, thank you very much.
I'm a bit confused because my impression was that these lending platforms on layer 2s have high capital at stake because they subsidize the interests. So isn't it a bit strange of a solution that they could actually diminish their risk by lowering their subsidies, instead of coming up with really complicated systems to mitigate the risk that they themselves cause?
Yeah, so basically what you say that, okay, maybe the solution is that they should, like limit their deposits or, just manage fewer funds. This is what you're asking?
Well, from what I understand, the reason that these numbers are so high is that people are farming the governance tokens.
Yeah, okay. So like in other words, you say, maybe right now they are less risky because no one actually borrowing anything. They just deposit or maybe loop their assets. Yeah, okay, that might, very well be the case. But, like eventually if you want to have like a real lending markets on these L2s, you will have to have a real activity there with borrowing, right? And, like real deposits. So or maybe another thing you say that, okay, right now there's not a lot of risk, because the activity there is not real in some sense. But yeah, okay, still, if you want to have a real activity in a real lending market, on your L2, you need to be aware of these things and take actions.
Thanks for the presentation. So it seems like you are more taking, or you're relying on third parties of like arbitrages and so on to execute the liquidations instead of doing it yourself. I mean, you could even do it like cross-chain. If you have like a lending on one chain, that USB Pro would then execute on another chain, and then you wouldn't need a delay. Could you maybe explain your reasoning? Is it because their centralized setups are more efficient in executing, or is there some other reason?
Yeah, no. Okay, so this slide is not very detailed, but this is not really a centralized setup. So here, so we have a backstop. For example, so like one integration we have is with, Liquidity, LUSD, which is actually on mainnet. But there they are, like right now around $15 million in user deposits. It's completely centralized in the sense that we don't control any of it. All users are free to deposits. None of the $15 million there is our money. And it's executed seamlessly without our intervention. Actually, the question for the doing some cross-chain or bridging of liquidity is very much in place. We are working and trying to find design partners for some cross-chain backstop and cross-chain liquidity. And this is definitely one of the missing pieces in DeFi. But right now, yeah, I mean, right now such primitive doesn't exist, but it's definitely something we try to work on.
So is the relying on arbitrages temporary? Or
Okay. No. So here, like relying on arbitrages. Okay, sorry, I didn't answer that. No. So actually relying on arbitrages. So eventually, if the backstop is imbalanced, then anyone can come and rebalance it. Anyone, So we started with USDC. Now we have ETH. Anyone can come and buy from it. And actually, like we did have a few millions of dollars that we rebalanced simply because we offered the best price and not because of a pure arbitrage. That's also happened. So yeah, like the first step is, okay, just offer the best price, or just offer market price, right? And then if it's very liquid assets on very active network, eventually someone will take it. But of course, if you get more imbalanced, then you have to, you are more anxious to sell. Then you will offer a lower price, and then eventually it will be taken by arbitrage bots. But the main difference here now is that it's okay if arbitrage bots will take it in steps. Maybe it even will take them hours to arbitrage. I mean, for example, we had GOHM on Arbitrum, which took more than a day to rebalance. But yeah, so it doesn't have to be arbitrage. Anyone can come and buy, but when the discount is low, it will be organic, organic flow. But when as the discount goes higher, then yeah, arbitrage bots will take it. Yeah. Okay. Thank you.
Thanks, Yaron.